everyone. Good morning. So, when we look at the outer space, we realize how vast it is, right? And it has so many undiscovered potentials. It is so complex. For centuries, we have been building a lot of tools to understand it, to make sense of it, to make sense of infinity. In today's business context, if we look at the data, it feels similar, isn't it? It is vast, it is complex, and for sure, it is brimming with a lot of potentials that we have not utilized. And of late, we have been thinking, we've been realizing that the tools that are given to us are not enough to explore the data that we have. And for that, we have created the system called Milky Way. Milky Way is not built just to solve one specific use case. We have designed Milky Way to be a platform that you could utilize in exploring the universe of data, in getting the root cause analysis done, and knowing what is going on with the data and helping the organizations. So today, I'll be taking you through what the Milky Way is and also giving you an understanding of how we've designed it. But before we go into what Milky Way is, right, let's first discuss the problem that we are trying to solve. And the problem is that we have a lot of data, but we really starve for decisions, right? There is a decision drought. The sheer volume of data that organizations have is just humongous. But the data analyst whom we hire to solve the problems, to give us the insights, on receiving a question, spend almost 80% of their time in pulling the data, making sense of the data, doing some cleanup, writing the codes and so on. And because of this, when they're done, it takes around 3 weeks time right now on an average for any enterprise to get answers to critical business questions. 3 weeks. In today's time, 3 weeks is like an eternity. In 3 weeks, you will have a lot of missed opportunities. 3 weeks basically tells you that there are ongoing inefficiencies in the system, and you're losing value each and every single day in terms of lost business opportunities. So we've come up with a system that would sort of help you solve this. And before we take a step forward in figuring out where we're going, let's just quickly take a look at where we are, where we were, right? We had this BI dashboards. We have had them for a long time. These BI dashboards, they are a rear view mirror. They tell us what happened yesterday, last quarter, last week. They're static, they're historical, they are helpful, but then they're static and with the limited scope into the view in the history. Then we had the first generation of AI copilots. These are conversational systems. You can think of these as conversational GPSs, where if you ask a right question, they will provide you with the way to get the right answer, but they are reactive. They would wait for you to ask the right question, right? So both of these systems have had a common limitation, a common bottleneck, a human bottleneck. Both of these systems would wait for a human to ask a right question. But what if that nobody thinks of a question that would uncover a dangerous threat or a big opportunity? If you don't ask those questions, you would never get those answers, and all of that remains hidden in the data. Now, to solve this, we have this next frontier, the proactive agentic systems. Now, what if your analytics system would not wait for you to ask a question, right? It works as expert analysts working for you 24/7. A system that is proactive, it is continuously scanning your data and looking for the faintest whisper of some threats and also assessing any budding opportunities. A system that is hypothesis driven. It is just not giving you a quick summary of the data, but also figuring out the hypothesis, the theories that it wants to test on certain business questions that you're asking, it is looking for whys. A system that is collaborative, it has intelligent entities that are purpose built for certain things. They're working together to solve complex problems. And all of this are built with a radical goal in mind. The current time we take to get to the output is weeks, and how do we reduce that to few minutes? So with that goal, we've created Milky Way, and the Milky Way is, as I was saying, is just not a single system or a single use case driven solution. It's a platform where we use constellation of agents to get to the insights faster. Each agent in the Milky Way has a unique capability to solve a specific aspect of the problem. And to understand how it works, we will take a use case. And for that use case, I would like you to introduce to our business analyst, Jane. Jane is a very sharp, smart business analyst working for a retail company. And one fine day, when Jane walks in, she sees the recent numbers have come in, and the revenue for Q3 has dropped by 15%. Now, this revenue drop would obviously need an analysis. And the natural question that comes to Jane's mind is, why did our revenue decline? Right? Now, in the old world, this will kick off a 3-week marathon that would start with a data pull, spreadsheet wrangling, countless endless meetings. But with Milky Way, it becomes prompt to the system, which kicks in the agentic process set up behind the scene and helps you get answer, helps Jane get answer in minutes. The solution to Jane's query is not a magic. It's a wisely engineered, thoughtfully designed, structured process. And now we will go into the details of what principles and tenets we have adopted to come up with the system that can solve Jane's problem. The first principle for design of a Milky Way or any agentic system like this is, do not send us generalists to perform a specialist job. You will not hire one person to be your CFO, your data engineering lead, and your statistician. And when you're not doing this with your organization, you should also not do that with your AI agents. When you build a system where one agent is trying to solve all the problems, you are creating a situation where you have a jack of all trades, but unfortunately, it is master of none. This leads to a situation where we have a slow system that consumes a lot of cost and is super efficient. In cases like Jane's, where the questions are complex, we build a team of specialists, right, that solves the problem, and they are purpose built for solving a specific aspects of the problem. Reason X, our orchestrator, works as a project manager. It receives the query from Jane and understands that it needs to invoke the domain agent first to add the company specific context to the revenue to make query more specified. The domain agent, post adding the right context, asking right clarifying questions, passes on the specified question to the data sufficiency agent. The data sufficiency agent looks for the availability of sales and the marketing data and sees whether we have enough data or not. Then, on availability of data, it passes on the control to the data quality agent that scrubs the data, figures out all the issues, cleans it up, and then passes it on to the hypothesis testing agent. Hypothesis testing agent then comes up with a plan and executes the plan. At a hypothesis level, it comes up with the outcome, and all of that then get passed to the reporting agent. A reporting agent takes in all this and creates a summary that Jane can easily understand, can take into the business and make some meaningful changes in the business to understand and to avoid any revenue losses. Now, the agents that you see here, these are just some example agents from a vast library of agents that we have built in the Milky Way. These were required to solve Jane's problem for this specific copilot, but for different copilots, we would have different agents coming up. Now that we have understood that we should not use just one agent for solving all the problem, let's discuss when you have too many agents, how do you sort of make sense and make sure that they are working properly with each other. When you have these different agents, you can connect them through various orchestration patterns. I'm pretty sure a lot of us here know about these different orchestration patterns that we have. You have a static router, you have graph-based systems, and then you have famous React, right? For a Milky Way system, what we have figured out is just using one is not enough. The system is a hybrid of some of these conversation patterns, the orchestration patterns. We have a backbone as a graph, but then we use the conversational loop using React at right places, and in some places we in fact have sequential chain. The orchestration pattern obviously depends on the problem, and with our expertise in solving the analytics problem, understanding the process, we have identified the right hybrid orchestration pattern that will help people get to the right insights and analytics on time, and we use that. Choosing a deliberate orchestration patterns not only ensures that you get the right analysis, but it also makes sure that you have an efficient system that takes least amount of time and also cost, but gives you the right outcome. Now that we have spoken about the deliberate orchestration, we need to keep few things in mind when we are designing it for real people, right? As we know that real life is not linear, real conversations are not linear. And the design of Milky Way is done in a way that when you ask a question that is not complete, for example, why is my sales going down? The system would ask you certain questions. It may ask, okay, do you want to do it for all products or just few of these? Do you want to do it for all regions? What is the time period? And so on and so forth. Now, when we ask these questions to the user, we also try to inspire user in figuring out how to contain the analysis in a way that we get most out of that analysis. Now, when Jane sees those questions, she sees, okay, if I do the analysis just for few product categories, which are mostly driving my revenue, instead of doing it for all, I may have more concrete insights that we can apply to the business. And she thinks, okay, let me ask this question, that what are my top categories? Now, a rigid system would fail because the systems that you usually see are not designed for these insight detours. But the way we have designed the system is through the stateful orchestration. First, we have made sure that the system inspires user to ask these detour questions to make analysis more meaningful for them. But then, when user asks these questions, we have built-in capability to detect these detours first, and then using the stateful orchestration, make sure that the main analysis get pushed in a stack, and a detour gets prioritized first. By running the detour, Jane gets idea about the top product categories and decides to do only for few and not for all. Once this detour is done, then the main analysis comes back up, where Jane has now more information to move forward. She can change the question in the ongoing analysis itself and then move forward with something that is more meaningful for the business. Now, a system that can deal with detours, has a multi-turn conversation capability, runs multi-step analysis, you can imagine that the context is going to be super, super big, right? And giving the right context in all LLM and agentic application is super important. At the same time, we can't just put everything from the history in the context, because then it will cause few problems. It will make the system slow because the LLMs will have to process a lot of data at any given point in time. It will increase the cost because the token usage will go up. But worst of all, what we have seen that if you have very large context getting processed, then systems, they start to make more errors. So the reasoning errors would be there. The agents will not be able to work very well, and this happens with every system that is out there. And to avoid all this, we practice very disciplined context engineering. We make sure that we have a very robust state management for each task, which acts as a single source of truth. We operate on the principle of least knowledge, where each agent is selectively given only information that it needs to run the analysis, to do its tasks. Additionally, in the real business scenario, we know that we would need certain specific knowledge that are related to the organization. We use long-term memory, the RAG-like system, or systems like Mem0 to retrieve the organization's tribal knowledge as and when needed, and including that in the solution prompt. This keeps the workspace clean and focused, and the accuracy of the analysis is usually much higher. Now that we have a context figure out, let's talk a little bit about UX. The system that we have built here is a system that is a data deep research system. It takes time to run the analysis. Something that is taking 3 weeks today now has been reduced to, let's say, 20 minutes. But if an analyst has to just wait looking at the screen, nothing happening for 20 minutes, it may not be a very good experience. This multi-agent system can feel like a black box to a user like Jane, right? And people do not trust something that they do not understand. Now, to solve this, what we have done is we have built Milky-Way, keeping transparency in the design as a core principle. When Jane is running this query, she sees the running commentary of what agent is currently working and what it is doing. For example, could say that domain agent is asking for additional information, the data sufficiency agent is checking metadata, the data quality agent is running the data cleaning, and so on and so forth.
Okay, sir.
And all these are just not status bar or status update. They, in our opinion, are a window into system thought process to the user. These help build more trust in the solution for users like Jane, and give them a confidence that system is really on the right track. While we want to do this and make sure that we are showing the thought process of the system to the user, there is a balance that is needed in deciding what to show to the user, so that we know the difference between the meaningful information and a cognitive load. Lastly, everything that system generates that are executable, such as SQL queries, Python code, the plans, are available for Jane to take up, edit, and make sure that the analysis is running as per her desires and needs. So doing all this ensures that user is engaged, believes in the system's performance, and able to understand what system is doing. Now that we have discussed about the UX, let's talk about a situation where rubber hits the road, the production reality. Now, creating a demo system is one thing. It is also very difficult, but making that work for the enterprises is a completely different ballgame, as all of us. The reality of production system is completely different, right? Now, let's say I have, in Jane's case, the agent is running and it's looking for answers to the revenue question. I cannot have that agent access to sort of HR data, for example. So the agent should get access to the data that they need for running the analysis. We call it the principle of least privilege. Giving the overall access to any agent is just a nightmare for all your CISOs, right? And we obviously don't want to do that. In production system, at the same time, when the number of users increase suddenly, the system should be able to survive that, should be able to work under that pressure. And to achieve that, what we have done is created our agents as a stateless containerized services that can scale on demand and scale very fast. Again, coming back to Jane's question, where she has asked a very complicated business question that may result in multiple hypotheses. Now, if we have these hypotheses run in sequence, then the overall analysis might just take too long. So we have designed system to execute asynchronously, make sure that jobs are running in parallel. By doing that, we make sure that we are running the hypothesis on product mix, the competitor action, and also the promotion at the same time, and providing the insights at the lightning fast speed. We also make sure that we are following all the right principles of sandboxing and centralized logging to make a robust, secure production level system. Now that we have touched upon production and principles related to that, let's talk about something that is required before putting solution into production and continuously after that, which is the evaluation and the testing of system, right? The LLMs are non-deterministic, and the conversation itself is the whole system works in a multi-turn, multi-step manner, right? So how do we know that system is any good? Whatever it is doing is making sense to the people, right? It is doing the right kind of analysis. Now, one could say that you can come up with the accuracy score. But as we know that a simple accuracy score, first of all, is very difficult to design in an LLM application. And second, even if you design by making some simplifying assumption, it will not just cut it. So what we have come up with is a hybrid evaluation system. Now this hybrid evaluation system uses the combination of automated evaluation, the LLM as judge, and also the human evaluation in places. In our experience, LLM as judge works well, but then obviously it's an automated system, so it is prone to error. So we make sure that for each LLM as judge system, we have taken some sample and have performed some automated or human evaluation on top of it. Then we make sure that we test each component and also end-to-end flow well, so that any change that we are making in the system is making a real meaningful improvement in the overall system. A system like Milky Way needs custom metrics to be defined so that you are measuring what really matters for the system. There are a lot of benchmark data sets that are available, spider, bird, and so on and so forth. But what we have figured out is it is important to test it on a domain-specific data set to make sure that when you deploy this in a production, it actually works, right? Lastly, we have also come up with a way to benchmark these purpose-built components against a minimal prompting using the same LLM to understand the incremental value that we are getting from writing these elaborate prompts and sort of designing the whole system. So by making sure that we are doing the right kind of evaluation, we make sure that system performs well for our users in the production time, right? Now, we have figured out the evaluation, production, the UX and everything. Now let's look at the results that Jane would be getting, right? What you see here is the results are just not some average numbers, but they are coming up with the reasons and the explanations. The revenue drop was 15%, but it was mainly due to apparel. And why did it happen? Because we reduced the marketing budget by 40% at the same time when our competitor doubled it. Now these are actionable insights. The system gives you recommendations as well on what you could do to make situation better for you. You could restore the marketing budget in this case, or run a premium bundle discount for your premium product, which is sort of covered in another insights here. So the Milky Way makes sure that it is giving you the analysis, the root cause behind the issues, and also recommending the solutions that you could apply and make things better for you. The results are not the end of the journey. Before we end the journey, there is one important thing that we need to discuss more. The last principle, and probably the most important principle, that we need to learn from each interaction. The system must learn continuously. Users, when they see a mistake happening from the system, would want that to be corrected. And if the system makes the same mistake over and over again, user will lose confidence in the system. At the same time, if user is providing certain answers which are not changing over time, user would expect system to know that and not ask the same question time and time again. A true copilot learns. We have baked in system for explicit and implicit feedback. At the end of the report, Jane can provide thumbs up or thumbs down and tell us whether the analysis made sense or not. At the same time, when Jane is using the system, she is changing certain queries, she is changing the hypothesis plan, she is deleting certain hypotheses or including few more from her end. We record all that and we use that to improve system not just for her, but for everyone who is using the system in her organization. So keeping the feedback data, using it to improve the system on an ongoing basis is probably the last but the most important principles of the system design that we have applied in designing the Milky Way. Now that I've spoken about all the principles that we have used and applied to design Milky Way, and I've introduced you to the Milky Way, you know that Milky Way is not just a single use case system. It's a co-pilot factory that we have built. It has a lot of agents that are purpose built and are domain agnostic. We have a very strong orchestrator that one could use in creating the co-pilots. We have industry specific agents already designed based on our expertise in those industries. With these, you will be able to create co-pilots very quickly. You can have a co-pilot quickly created for supply chain that understands logistics and route planning. At the same time, you can have one created for HR that understands attrition very well. These co-pilots, while they have the industry knowledge, they are built to absorb the tribal knowledge of your company and learn from each interaction. In our opinion, these are future-proof. This is a future-proof investment for your company, and it will become more valuable, one interaction at a time. Lastly, what we believe in Tredence is the universe of data is going to become just more complex with time, just like our own universe. And with Milky Way, we are not just giving you telescopes, we are giving you autonomous explorers that you can use to uncover the potential of the data and make more value for your business. Thank you for listening. I am happy to take your questions, and we have a booth where you can just explore the Milky Way Milky Way system firsthand. Yep.